This is a presentation of Chapter 4, Section 6 in the 8th grade textbook, Estimating Square Roots. There are two unique parts to this presentation. The other part of the presentation covers the extension to Chapter 4, Section 6 that you'll find in the math textbook. If you're looking for that content, it is in another video presentation. Please return to where you came and find that particular video presentation. This will cover simply the material that is in the note-taking guide. In Chapter 4, Section 6, we're talking about estimating square roots here. Now, when we've talked about estimating square roots in the past, one of the things that we did is apply the concept of the squeeze method. The squeeze method helps me narrow down on a square root that is not a perfect square root through a process of iterations. We're not going to spend so much time on that today, although we can apply those concepts that we learned there. But all we're going to work on here is estimating either perhaps with a calculator or by using nearby perfect square roots and then maybe some numbers that surround them. So a lot less steps mathematically than perhaps we would involve with the squeeze method. So the first question here says each square root is between two consecutive integers, and we are supposed to name those integers and then explain our answer here. So what we want to do first, before we start talking about where these numbers fit here, is we want to go ahead and look at writing down some of those perfect square roots, because that's what's really important, is where these numbers fall in between. So remember, when we take 1 and square it, the result is going to be 1. When we take 2 and square it, the result is going to be 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared, 8 times 8 is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. Now the reason we're talking about the squares is because going in the opposite direction, remember, it's a list of square roots. So what we have here that we just wrote is the list of perfect square roots. We're going to figure out where this number fits that they're giving us in the particular question on that chart, figure out then, after where it fits, what those numbers equate to as those square roots, and that will be where my solution lies in between. So when we're looking at question A, the number 55, 55 obviously fits in between 49 and 64. Well, we know that the square root of 49 is 7. The square root of 64 is 8, which they're showing you right here. Well, obviously then, as 55 is between the square root of 49 and the square root of 64, rather the square root of 55 is between the square root of 49 and the square root of 64. And we know that the square root of 49 is 7 and the square root of 64 is 8. That means this value here, whatever the square root of 55 is, has to be something that is between 7 and 8. Now, as we go ahead and take a look at the next question, the square root of 90, we see first off that there's a negative sign in front of that. Don't let that fool you and don't let that confuse you, because oftentimes we've talked about that there is no such thing as the square root of a negative number. The negative is not under the root, however. We're not taking the square root of negative 90. The negative being out front means take the square root of 90 and then change the sign. So that's not going to be a problem for us. So here, square root of 90 fits on this chart between 81 and 100. So the square root of 81 equates to 9, which is what they're showing you right here. The square root of 100 is going to equate to 10, which is what they're showing you here. Well, obviously the square root of 90 would fall in between the square root of 81 and the square root of 100, just based on pure numerical order. So with the square root of 81 being 9, the square root of 100 being 10, the answer is going to fall somewhere between 9 and 10. Now what we have to remember though is there was this negative out front that we've already discussed. So what we're going to do is we're going to change the signs on those and make them negative. If they were negative, they would have become positive, but that's not really applicable here. But that's all we're doing, is we're changing the signs. So we're going to say that the square root of 90 is somewhere between the square root of the opposite of 90 is somewhere between negative 9 and negative 10. Now if you want, you can go back and verify this on a calculator. Go back to A, where they asked us to find the square root of 55. If you put in the square root of 55 on a calculator, the solution is 7.416, 198,487. Well, remember, we said the answer is between 7 and 8. 7.416 does indeed fall in between 7 and 8. So not only do we see why it works based on numerical order, but we see that it works factually, having then said this is the answer and then checking it on the calculator and seeing that that response does indeed fall between 7 and 8. All right, let's go ahead and continue down here onto the next example. In question number 2 here, it says you want to sew a fringe on a square tablecloth with an area of 500 square inches. Calculate the length of each side of the tablecloth and the length of fringe you will need to the nearest tenth of an inch. So here they're saying you've got a square tablecloth, a perfect square, and they're saying that the area of this square is 500 inches squared. Well, remember, in order to find the area of any rectangular shape in this form, all right, we're going to multiply together the length and the width. Well, if it's a square, the length and the width have to be the same. So I'm saying what number squared is going to equal 500? Well, what they're doing here then is they're going and doing that same approach that we did in question 1 here on question 2. Obviously, the number is a little bit bigger here, but what they did is they figured it out for us. They said it's somewhere between 22 and 23. Now remember, the way to verify that is to square those numbers. When we take 22 and square it, that is a result of 484. 23 squared, that is 529. Remember, we're working with 500. 500 would fit in between 484 and 529. And remember, as we're reading the other way, we're talking about square roots. We squared them, but read backwards, it's a list of square roots. So the square root of 484 is 22. The square root of 529 is 23. So now that we have that, we know our answer has to be somewhere between 22 and 23. So what they do first here is they do much like we would have done with the squeeze method. They go perfectly halfway in between those two numbers and see what the result is. Well, if we go halfway in between, that's 22.5, and we square it and we get 506.25. Now that number is too big. And because it's too big, we're going to have to test something smaller to see if it works. Remember, our goal when we square that number is to get as close to 500 as we can. So what they do then is they go down to 22.2. They just pick something smaller. Now, if we were doing squeeze method, again, we would go halfway and test 22.25. They've just tested 22.2 here. When we take 22.2 and square it, we get 492.84. So not only did we get too small, we went to the other side of 500 there. So obviously what that implies is we've gone too far to the left on the number line, so we're going to bring it back to the right a little bit, and they're going to test with 22.4. When we square that, we get 501.76. That's the closest we've gotten to 500. We're only 1.76 off, but we're still a little bit too big here. So we're narrowing down here based on that. We know the answer is somewhere between 22.2 and 22.4 here. This was the closest one we've had so far onto the too small side. This is the closest one we've had, but it's on the large side. So we're going to go in between and see what that does for us. 22.3 squared is 497.29. It is too low, but it is closer than this one was. So we now know our answer is somewhere between 22.2 and 22.4, this being the closest number too small, this being the closest number too large. And that's what they're explaining down here at the bottom. So where they've gone next then is they take 22.35, which would be in between my nearest numbers, 22.3 and 22.4, and they've squared that. And when we do that, we get 499.5225, which is too small, but it is very, very close. And because we're very, very close, that helps us to know that we're right in that ballpark. So what they do then, because it is just an approximation here, what they did then is they rounded this up just a smidge to 22.4, and they said that each side of the tablecloth is about 22.4 inches long. Of course, we know that the result there was 501.76, which was very close, we did that back up here. That is a good approximation. It's not an exact value. None of these will give you an exact value unless you do perhaps hundreds or thousands of iterations going through this process many, many times, and that's not the point here. The point is to see how we come close to that value by the process of elimination. And that's what we've done here as we've gone through this particular problem. So, as we finish this question out now, they're asking about the perimeter, because remember, what the question here is about is how much fringe we will need to go around the tablecloth. Well, if we know each side is approximately 22.4, and obviously there are 4 sides here, we're going to take that 22.4 number we figured and then multiply by 4, and that result is 89.6. So we're going to need about 89.6 inches of fringe. 90 would not be a bad approximation there, because remember, that 22.4 figure in itself is also an approximation. Alright, so let's go ahead and take a look here at question number 3. They're asking me to estimate the square root of 141 to the nearest hundredth. So this is more of that approximation technique that we've been using. Obviously, you want to start off with the knowledge we have of those perfect square roots. We've already gone through some of them. We'll have to extend the list a little bit here, but we know when we take 10 and square it, the result is 100. 10 times 10 is 100. When we take 11 and square it, the result is 121. When we take 12 and square it, the result is 144. And that's really as far as I need to go here, because I've gotten to values that surround the number in this particular question, which is 141. 141 is going to fit in here between the 121 and the 144, meaning my answer we now know is somewhere between 11 and 12. And that's where they start here in this first step here. They're explaining why that fits in between 11 and 12. So, as we continue on there, what they do is they go ahead and then find the difference between the given number, 141, and the lower perfect square. We know that the answer is not going to be 144 because that is a 12 number. Anything bigger is also going to start with 12. So here that wouldn't make any sense. So 121 is where they're going to go to, because this is going to automatically generate something that's too big. This number is what the value is going to start with. We know just by that process of elimination, because this is 12 even. Anything less has to be less than that 12. So that's why they're going down to 121 here. So as you can see, they're going to go ahead and do some subtraction there, finding the difference of 141 and 121, which is 20. Then finding the difference of 144 and 121, which is 23. And then what you're going to do is you're going to write that difference as a ratio, comparing those two differences, 20 over 23, and then dividing, which is equal to or approximated to be 0.87. As you can see, when you get that on a calculator, 20 divided by 23, that's actually 0.869565,217. And again, they've approximated that to be 0.87.